So we're asked to use the second fundamental theorem of calculus to define some function f of x that has a derivative that is e to the x squared and f of 3 equals 5. Now of course the issue to this is there's no nice analytic antiderivative of e to the x squared. But the second fundamental theorem of calculus says that we can say, alright, well then capital F of x is the integral from some value up to x of e. Now we can't use x here, so we use what's called a dummy variable, t squared dt, because now we know that the derivative of this function is e to the x squared from our second fundamental theorem. So that satisfies this part. The next part we need to satisfy is that f of 3 must equal 5. Now, to not have to do a lot of work, what we can do is we can set that lower limit to be 3. And the nice thing about that is now look at what happens when x is equal to 3. I would have the integral from 3 to 3, which we know by properties of integrals is 0 automatically, and that means I just have to add 5 to the end, and now we have a function that takes x as an input, gives out values. They'd have to be numerically computed, but it gives out values for each input x.